They were digging a well when they hit something that made them stop mid-swing. Their shovels struck stone, and as they cleared the dirt away, the farmers saw blocks, lined up like bricks in a fortress wall. It happened in Texas in 1852. But to this day, there's no single explanation for something that looks like a secret buried city beneath quiet streets and front lawns. The diggers who found the well said that the structure stretched for miles. In some places, it dropped dozens of feet below the surface. The stones looked strangely orderly, almost like someone had stacked them, and in certain places, the shapes even formed arches. Other sections looked like windows or steps climbing upward. Before long, people started calling it the Great Wall of Texas. And the story spread quickly. Farmers, builders, and curious locals all grabbed shovels and started digging around, hoping to figure out what it really was. And that's when they noticed that the blocks seemed separated by seams that looked suspiciously like mortar. It was really hard to believe that nature could stack limestone into right angles and parallel lines like this. Then, things got even stranger. In 1886, a local newspaper wrote about a massive petrified skull found near the wall. They also mentioned underground chambers, lost rooms beneath Texas soil, and relics of something powerful and old. And then, almost as quickly as it appeared, the story vanished from print. There were no follow-up articles, no skull preserved in a museum, no official investigation that anyone could point to. It was as if the story had quietly slipped out of existence. People got even more intrigued and wanted to know if someone had suppressed all the info about the find on purpose. Someone suggested that some powerful institutions had quietly removed artifacts. Over time, theories piled up. Lost civilizations, ancient giants, even a North American counterpart to the Great Pyramid. But then, modern science stepped in with drilling rigs. Geologists drilled deep into the formation and pulled out samples of the rock. Then, they ran paleomagnetic tests. When rocks form, tiny magnetic minerals inside them line up with Earth's magnetic field at that moment, almost like microscopic compass needles frozen in place. If workers had cut these blocks somewhere else, maybe dug them out of a quarry, and then transported and assembled them into a wall, the magnetic patterns inside the rocks would have pointed in different directions. Each block would carry the signature of the place where it originally formed, but every sample had the same magnetic orientation, which means the stone formed exactly where it sits today. Researchers figured out the wall was made of rare limestone. This material can fracture in surprisingly straight lines as it hardens underground. Over long periods, erosion opens up those fractures, and they can look exactly like human-made walls. It's like mud. When it dries, it splits into neat geometric patterns. Now imagine the same process happening underground, slowly over millions of years on a much larger scale. Today, the scientists are sure that the rock wall formation developed naturally. It only seems constructed by humans. Recently, a family whose ancestors were early rock wall settlers donated a piece of land to the city that has the original site where the wall was excavated. And because the interest in the place lives on, the city authorities plan to make the original wall accessible to the public. The rock wall isn't alone. In 1968, 3 divers spotted large rectangular limestone blocks near North Bimini in the Bahamas. The blocks were in a straight line stretching about a half a mile. Divers called it the Bimini Road. It consists of massive angular blocks of limestone. Some of those blocks are up to 13 feet long. Many of the blocks look like they once had right-angled corners, as if someone cut them and placed them there with purpose. The 3 divers found this construction when the world buzzed with interest in Atlantis. So headlines immediately connected the dots and were seriously asking whether this could be the first physical trace of Plato's legendary civilization. We still don't have any archaeological evidence to confirm it actually existed, but the timing and the shape of the Bimini stones made many people believe that was it. But then, geologists explained that beach rock forms when sand, shell fragments, and other coastal sediments cement together in warm, shallow water. The Bimini blocks consist of small mud pellets, grains of sand, shell pieces, remains of tiny single-celled marine organisms, and fragments of algae. Over time, chemical reactions bound these materials into solid limestone sheets. Natural fractures split the sheets into rectangular blocks. As sea levels rose at the end of the last ice age, water gradually submerged the formation. Waves and currents eroded the sand beneath parts of it and made some blocks look slightly elevated or recessed. Then, researchers did radiocarbon dating on rock samples, shells embedded with them, and the carbonate cement holding everything together. That's how they found out that the stones were roughly 2,000 years old. It's way after Atlantis' supposed demise 12,000 years ago. So no, the Bimini Road doesn't lead to Atlantis. But it helped scientists better understand how coastlines evolve, how sediment hardens, and how rising seas reshape continents. There's another mysterious structure that might have to do with Atlantis. Meet the Eye of the Sahara, or more officially, the Richat structure in Mauritania. From space, it looks like a 25-mile-wide bullseye carved into the desert. Concentric rings ripple outward like someone dropped a cosmic pebble. People who saw it first thought it was a spot left by a meteor impact. And a new theory links it to Atlantis. They say it looks exactly how Plato described it, with a center island with 3 rings of water and 3 rings of land around it. The Eye of the Sahara sits totally dry right now, but imagine if you dropped it down to sea level. Ocean water would rush in and fill those dips, and boom, you get something that looks a whole lot like Plato's famous city. On top of that, the size seems pretty close. Plato said the main part of Atlantis measured about 11 miles across, and the Richat structure measures roughly 13 miles wide. But wait, Atlantis famously sank into the ocean, so for this to work, the eye had to sit right at sea level a long time ago. The fans of this idea claim that this whole chunk of northwest Africa slowly pushed upward over the last 11,000 years. They say it sat right at the ocean's edge way back around 9,600 BCE, which is exactly when Plato's story takes place. To back this up, they point out tons of salt inside the rings in satellite pictures, saying this proves ocean water used to sit right there. They also see sand all around the eye that looks like a giant wave washed over it. A huge wave like that would totally wipe out any city sitting there, just like the wave that supposedly sank Atlantis. It all sounds pretty convincing, but actual scientists and historians totally disagree. Because when you look closely, the facts just fall apart. Yes, the eye has 3 clear ridges, but if you measure all 3, the whole thing stretches way bigger than 13 miles. On the flip side, if you only measure out to 13 miles, you have to leave out the 3rd ridge entirely. So it doesn't actually match Plato's description perfectly, since you simply can't have it both ways. Modern satellite images show that the eye formed from uplifted rock layers that were pushed upward by molten material beneath the surface. Wind and water erosion then peeled back those layers like an onion over at least 100 million years. The oldest rocks sit in the center. Younger layers ring outward. It's a geological dome, not a crater, not a city. Inside the structure, scientists found igneous rocks, hardened magma, and sedimentary layers twisted by immense pressure. Hot water chemically changed the rocks and left additional signatures. Ancient stone tools also scatter across the region, showing that early humans once passed through. This site is now among the most significant geological heritage locations on Earth. The Sahara Desert is home to highly dangerous creatures like the death stalker scorpion and the desert horned viper, but they're nothing compared to a mysterious beast that lived there 95 million years ago. Scientists just found a new dinosaur species in the Sahara Desert of Niger. His official name is Spinosaurus mirabilis, and let's just say you wouldn't want to cross paths with him. This beast was as long as a school bus and weighed several tons. He was a massive, powerful predator. His whole body was built to hunt. He used a trap-like jaw to catch the largest fish prehistoric Africa had to offer. His bottom teeth actually poked outward, fitting perfectly between his top teeth to create a tight grip. Once those jaws closed and trapped fish, they couldn't get away. His name, mirabilis, actually means astonishing in Latin. And that's because this dinosaur was a showstopper. He had a really flashy, weird feature: a tall, really tall, crest on his head. It was so big, the researchers actually had to go back to the site and gather more pieces just to make sense of it. Today, it's all just bones, but the team thinks that when he was alive, that crest was brightly colored. It curved up toward the sky like a glowing blade. And being that flashy had one main goal: to attract mates. It worked just like peacocks with their long, bright tails. It's all about showing off for their love interests. At least, that's what researchers think. This discovery is huge because it's only the second Spinosaurus species we've ever found, like the one that starred in Jurassic Park 3. These guys were among the biggest terrestrial carnivores of the late Cretaceous period. That is, meat-eating dinosaurs that lived about 100 to 66 million years ago. They were as huge and fierce as the famous T-Rex. For a long time, most people thought Spinosaurus were aquatic hunters, and we pictured this fierce monster stalking the shore or diving deep to hunt. Some research even suggests their long spines on the tail were basically built-in flippers. But that's not what most scientists believe anymore. New studies show that while the paddle-like tail looks great for swimming, it didn't actually have much muscle. It turns out those tails were likely just for show, kind of like a lizard tail. They just didn't have the power to push such a massive creature through the water. The density of their bones didn't help either. The bottom line is, they wouldn't have been terrible swimmers. They were super slow and couldn't really dive. To give you an idea, if we put this dinosaur next to a crocodile in a pool for a swimming competition, the crocodile would win every single time. Whether they were swimmers or not, scientists seem to agree on one thing: these guys loved the sea. Most of their fossils were found along the North African coast. But then, the Mirabilis species showed up and totally changed the game. These were found in the Sahara, where there isn't a drop of water in sight today. Back then, this spot was about 300 to 600 miles away from the nearest ocean. So what's the story here? Is this actually a Spinosaurus? Well, it sure is. And the way scientists actually tracked it down in the middle of the desert is pretty interesting. Because for over 70 years, the main clue was right there, easy to find, but everyone missed it. Back in the 1950s, some French geologists were out in the desert looking for uranium. While they were searching, they stumbled upon these massive bones poking out of the sand at a place called Gadufawa. Nearby at another spot called Acarazeras, a geologist named Hugues Faure found a different fossil site. He found teeth that looked a lot like the ones from a Carcharodontosaurus, which was a massive carnivorous dinosaur. He wrote down one single line about it in his notes, and that was basically it. For some reason that nobody can explain, those notes just sat there. No one took them seriously or even bothered to go back to that site for decades. It wasn't until 2019 that a team led by Paul Sereno from the University of Chicago decided to finally follow that old lead. They basically turned it into a high-stakes treasure hunt. They headed out there, and a local Tuareg man led Sereno's team on motorbikes deep into the Sahara. He took them to a site called Jengwebe, where he remembered seeing fossilized bones a long time ago. Because it was such a long trek back to their main camp, the team didn't have much time. They could only grab a few fossils, mostly teeth and pieces of jaw bones, before they had to leave. At that moment, they had no idea they were holding a brand new species in their hands. The team finally headed back there in 2022, and this time, they found even more fossils. That's when they finally put together the 40-foot-long find. And then they were able to confirm three big things. First, this new creature had a really tall and unusual crest on its head. Second, the way the teeth were set was a bit different from its famous relatives. And then we come to the biggest difference of all. For the first time ever, we're seeing a Spinosaurus that lived far from the ocean. But that raises a big question. How did it eat fish? Scientists have a theory. All those bones were found buried in the sediments of an ancient river. That means this dinosaur probably hunted for fish in shallow water. It was big and strong enough to wade into water over 6 feet deep. but it probably spent most of its time in shallow water, just waiting for a big fish to swim by. But if it didn't feel like sushi dinner, it could just wander through the woods and pluck something else to eat. Okay, so you're probably a little confused right now. I'm talking about forests and rivers. But wasn't this thing found in the middle of a desert? Well, the thing is, the Sahara looked completely different back then. It was actually green. The whole landscape was full of rivers and forests while these dinosaurs were roaming around. So that pretty much solves that mystery. But there are still plenty of other questions about this species, like how big they actually were. See, the problem is that the bones we found belonged to a young dinosaur, not a full-grown adult. Estimates say that the creature was probably about 26 feet long when he lost his life, but he could have grown a whole lot bigger than that. That leads us to the second mystery. Because this dinosaur was so huge and looked so unique, scientists have been arguing for years about how much time it actually spent in the water. One theory is that they went through 3 big evolutionary phases. First, way back in the Jurassic period, they started developing these long, crocodile-like snouts. They were perfect for catching fish. Second, during the early Cretaceous, they really started running the show. They moved toward the sea and became the top predators along the ancient coastlines. The final phase happened right as the Atlantic Ocean was opening up. This is when they reached their record-breaking size. They basically became shallow water ambush specialists, sticking mostly to North Africa and South America. But their reign didn't last forever. Around 95 million years ago, there were abrupt changes in the climate and the sea levels increased a lot. Basically, that affected the habitat they lived in, pushing them to the brink. Eventually, their story came to an end. Unfortunately, these new fossils are only part of the puzzle. We still don't know the whole story about Spinosaurus. There might even be other species out there just waiting to be discovered. And to really understand these mysterious giants, we'll have to wait until we find more complete skeletons out in the field. We all know how it goes. Homo sapiens are way smarter than Neanderthals. Neanderthals were primitive, and we're much cooler than they were, right? Now, what comes to mind when you hear the word factory? Probably something like this. Lots of Homo sapiens, people, working in different departments, huge production lines, packaging, sorting. You can't fit a Neanderthal into that image, can you? Hey, don't be such an evolutionist. We don't judge people here by the stage of their development, okay? And by the way, Neanderthals had their own impressive factories. No conveyors or industrial robots, but pretty advanced for their time. The production line I'm talking about was located in a place we now call Germany. What's funny is that it's a country that still has plenty of factories and a long tradition of working with machinery, so it feels like a continuation of that tradition. Now, poof, back 125,000 years, to the moment when this very early factory appeared. Around this time, Earth was in an interglacial period, with weather quite similar to today's climate, so conditions may have not been the best, but still fairly comfortable. Neanderthals lived their ordinary lives. They used fire to manage vegetation, gathered plants, and apparently, built plants. Pun intended. So if you thought those hairy guys were savage beasts who spent their time scratching lice off their skin, you may owe an apology to this distinguished gentleman. By the way, this is Carl, and he claims to be the owner of this factory. You seem to have underestimated him, so he's left. But I'll carry on talking about this interglacial breakthrough. Archaeologists have recently shown that Neanderthals intentionally chose a lakeside location to process the bones of at least 172 mammals, including deer, horses, and aurochs, a now extinct species of bovine. The study demonstrates that the inhabitants not only broke open large mammal bones to extract marrow, but also ground the bones into thousands of fragments and heated them in water to extract calorie-rich bone grease. Think of it as a food manufactory making flavorful Campbell's soup ready to hit the shelves at your local supermarket. I know it sounds far-fetched, but what I want to show here is that we now have evidence that even Neanderthals had pretty advanced techniques of food processing. This was intensive, organized, and strategic. Neanderthals were clearly managing resources with precision. Some of them were planning hunts. Others were in charge of transporting carcasses, while another group was busy rendering fat in a task-specific area. They definitely had no nutritionists, but they did understand both the nutritional value of fat and how to access it efficiently. Just one example. Scientists now think that when it came down to caching carcass parts, they would do so across the landscape for later transport to the grease rendering site. You know how all factories are supposed to meet production targets? Same here. Experts believe Neanderthals understood there was a certain fat quota they needed to meet to make the literally bone-crushing process worthwhile. Now, you may say, well, it's just one example. It doesn't mean that Neanderthals were that advanced. True, good catch. However, there are more examples, and here's one of them. Technically speaking, in addition to food-related production lines, these guys may have had a chemical production factory. You see, there is evidence that Neanderthals made stone tools using a multi-ingredient adhesive, which they couldn't buy at Dollar Tree for very obvious reasons. The factory headquarters wasn't in Germany this time though, but in Gibraltar, in Vanguard Cave to be more precise. While studying this area, scientists stumbled upon a small hearth that may have functioned as something close to an ancient adhesive workshop. So chances are that Neanderthals were using fire not just for warmth or cooking, but as a controlled tool for producing useful materials. Now, let's see how this hearth worked. If you've ever cooked sauces, you know how they thicken once the temperature goes up. Neanderthals may have spotted something similar while using fire for its basic function, cooking. They put two and two together, and bam! They started glue, or rather, tar production. The controlled fire helped them regulate heat precisely enough to produce a perfectly sticky texture. That tar could then be used to fasten stone blades or other sharp pieces onto wooden handles, with sinew or plant fibers helping secure the joint. If you wonder what the recipe was, scientists managed to reconstruct it. Sort of. Basically, it involved burned rock rose leaves, but there was a secret ingredient for the process to work: guano. Guano is what's left of bat and bird feces once they've decayed. It sounds quite disgusting, but it worked, and that's what matters. Let's check out the structure itself. It's quite small. A round pit roughly 9 inches across and about 3.5 inches deep. Its walls are sharply cut, and 2 narrow trenches extend outward to the north and south. The working idea is that Neanderthals packed the pit with rock rose leaves, then sealed it with damp sand and soil, likely mixed with, you guessed it, guano, to limit oxygen entering the chamber. A small fire, probably fueled by grasses and shrubs, would have burned above the sealed pit. As the plant material heated, it released a thick brown resin. Producing that resin required temperatures in the neighborhood of 300 degrees Fahrenheit or more. However, it took scientists some effort to understand what happened inside the hearth. They had to analyze residues from the walls and floor using several chemical techniques, including mass spectrometry. This technique identifies and counts molecules within a sample. It was necessary to reconstruct the likely production method. Once they ran those smart tests, they moved on to the next step, which involved a tad of elbow grease. They recreated the setup themselves, building experimental hearths that matched the original in size, shape, and materials. In 4 test runs, the recreated hearths successfully produced resin, which supported the proposed explanation. Alright, it feels like those prehistoric production lines prove that Neanderthals were much cooler than we thought. A typical idea is that Neanderthals were just wandering hunters, but they probably were not. And it's not only about their production setups. There may be evidence suggesting they organized coordinated hunts that lured wild horses into traps roughly 200,000 years ago. We go back to Germany once again. At the archaeological site of Schöningen, researchers uncovered wooden spears, double-pointed sticks, stone tools, and the butchered remains of more than 50 horses of different ages. After a couple of tests, scientists realized these finds are about 100,000 years younger than earlier estimates. The material was excavated in the 1990s from sediments along what used to be a lakeshore. With the updated dating, scientists think the site reflects a period when Neanderthals were already living across Europe. Zoo archaeologists argue that these hunters could understand horse behavior well enough to organize group hunts, steering entire horse families toward carefully chosen ambush points. Yikes! Chances are that by about 200,000 years ago, Neanderthals were cooperating in increasingly complex ways. Organized hunting, shared planning, and coordinated action may have been part of their social life, and they could have possibly reached levels similar to those seen in early Homo sapiens communities. Earlier estimates placed the Shonengan tools and horse remains at roughly 300,000 years old. There were no labels, of course, so scientists had to turn to pollen preserved in the sediment layers, which they used to match local vegetation changes with known global climate cycles. Under that older timeline, the hunters at the site might have been Neanderthal ancestors, or another ancient human species known as Homo heidelbergensis. But the new timeline points more directly to Neanderthals themselves. To refine the age of the site, a team of scientists analyzed how amino acids, the chemical components of proteins, had gradually changed structure after passing. They examined 4 snail shells, 15 tiny crustaceans, and 8 horse teeth from the same sediment layer that contained the spears. Once they measured these molecular changes and combined the results with pollen records and climate data, the researchers calculated how much time had passed since those organisms died. The results consistently pointed to a younger age, around 200,000 years, placing Neanderthals squarely in the role of the hunters behind the Shonengan horse drives.
So, check out this creature. What do you think this thing is? Is it a plant, an animal, or maybe even some kind of wild fungus? At first glance, this fossil could pass for any of those ancient life forms. And honestly, scientists have been scratching their heads over it for over 150 years. But now, it looks like we might finally be cracking the case on this unknown species discovery. A long time ago, during the Devonian period, plants were just starting to grow on land. The tallest trees were only a few feet high, and animals hadn't even evolved backbones yet. Back then, massive natural towers up to 26 feet tall and 3 feet wide, looking like branchless cylindrical tree trunks, were rising from the ground. Hey, what a contrast with trees back then. When scientists first discovered fossils of those towering organisms, they were totally confused, as these strange prehistoric creatures didn't look like anything they'd seen before. Some thought they were weird cone-bearing trees. Others guessed they might be underwater plants like giant seaweed or lichens, which are partnerships between fungi and algae. The mysterious objects received a name, Prototaxites. When scientists studied them up close, their internal structure reminded them of a bunch of different things. They couldn't believe a 20-foot-tall fungus or algae could be real, but that's what the fossils showed. Then most scientists decided that Prototaxites were giant fungi. But still, something didn't feel right about it. In 2007, they decided to finally get the Prototaxites mystery explained and ran a chemical test on the fossils. So they looked at the types of carbon inside them and compared them to regular plants from the same time. If Prototaxites were plants, the carbon ratios would match, but they didn't. That means Prototaxites weren't plants, and they receive carbon in a different way, not by photosynthesis, but probably more like fungi do. But then again, they look nothing like the mushrooms we know and love today. Prototaxites were giant, likely the largest living things on land at their time. And even if these strange prehistoric creatures were some fungi of their sort, then it's weird they don't have any living relatives today that would resemble them. So, if we put all this together, it looks like Prototaxites are an entirely different and previously unknown life form that didn't leave any offspring. Now, Prototaxites aren't the only unclassified organisms on Earth. About 600 million years ago, there were no fish, no sharks, no crabs, just simple life forms like algae and bacteria drifting through calm, shallow seas. But some seriously strange creatures, completely unlike anything we see today, lived among them. They look like underwater ferns, stood perfectly still and absorbed nutrients straight from the water. These bizarre life forms were rangeomorphs. They ruled the oceans that were thick with nutrients back then. So rangeomorphs didn't need mouths, eyes, or muscles to survive and just soaked up whatever they needed. Some of them were as small as a finger, and others grew as tall as 6.5 feet. But as Earth entered the Cambrian period, the oceans became much more competitive. Fast-swimming creatures with limbs, eyes, and jaws showed up and ate the same food faster, and maybe even ate the rangeomorphs themselves. The chemistry of the oceans also started to shift, and the nutrient-rich waters became more like today's oceans, where food floats around in particles that active animals scoop up. So the rangeomorphs vanished forever, but scientists still find their fossils all over the world, preserved in ancient rock. They had an incredible fractal design, a pattern that repeated itself at every level, from the smallest branches to the full body. Using fossil clues, researchers built 3D computer models of what rangeomorphs looked like. They found out that these strange prehistoric creatures filled their space in a nearly perfect way. They were like optimized living sponges. But scientists still can't agree on where exactly rangeomorphs fit on the tree of life. At first, they argued over whether they were plants, animals, fungi, or something completely different. Now, most agree they were primitive animals, though they were so different that they might deserve their own unique branch, what scientists call a clade. And then there was Dickinsonia, another prehistoric creature that was so strange that scientists couldn't even agree on what it was for nearly 100 years. Some thought it was a giant single-celled amoeba. Others thought it was a type of lichen, or maybe a failed evolutionary experiment. This bizarre life form lived about 558 million years ago, long before dinosaurs, sharks, or even insects showed up. After many years of studies, Australian researchers finally got proof that Dickinsonia was an animal, and possibly the oldest one scientists have ever found. They solved the mystery thanks to really well-preserved fossil fat molecules stuck in the rock near the White Sea. These molecules were a type of cholesterol, the kind of fat found in animal cells. If cholesterol is present, it almost certainly came from an animal, sort of like animal DNA. Dickinsonia lived millions of years earlier than scientists had previously thought, and didn't look anything like modern animals. It had no head, no mouth, no arms, no legs, and definitely no organs. It was oval-shaped, like a giant pill bug or flattened jelly bean, with weird ridges running across its body. Some were tiny, but others grew up to 5 feet long, the size of a person. It didn't swim or walk, but was just lying on the seafloor, soaking up nutrients from the water or absorbing stuff through its skin. It was tricky to identify because most fossils came from high-pressure rock, where heat had destroyed all the delicate organic stuff scientists needed to study. To get to the good fossils, researchers had to rappel down 300-foot cliffs, dig out huge blocks of sandstone, throw them down, wash them, and then repeat the process. And inside one of those sandstone slabs was the fossil that changed everything. That helped finally confirm that Dickinsonia was an animal, which proves that complex animal life existed before the Cambrian diversification, where tons of new animals with bones, eyes, and limbs suddenly appeared. Scientists think the spot where they found these fossils might hold more clues about ancient life. For a long time, scientists had no clue what other group of ancient life forms, slime molds, were. These weird jelly-like blobs that pulse and ooze on rotten logs and forest floors aren't fungi like mushrooms, though people thought they were for years. It turns out they're more like amoebas, squishy, single-celled organisms that can move around. There are over 900 species of slime molds all over the world. You'll find them in soil, leaf litter, and especially on decaying wood. Scientists found them trapped in amber from 100 million years ago, and it looks just like modern slime molds. Scientists still know very little about how slime molds interact with other species, what role they play in ecosystems, or how they think without a brain, nerves, or a control center. But somehow, they can make decisions and adapt to their surroundings. That makes them a lot like social insects, like ants or bees, where no single bug is in charge, but the colony still works together as a smart group. Even without brains, scientists have trained slime molds to solve mazes just by responding to chemicals and learning from their environment. One way these organisms learn is through a process called habituation. It's sort of like how you get used to cold water after jumping in a lake, or stop noticing an annoying buzzing noise after a few minutes. That's your brain helping you tune out something harmless. Some slime molds can do this too. If they get in nasty conditions, like salty, dry, acidic environments or chemicals, they'll avoid them at first. But if there's food on the other side, they'll eventually get used to it and push their way through. And if you let slime mold go dormant and wake up a year later, it still remembers how to deal with salt. They even seem to be able to decide where to go based on where they found food in the past. With more and more unknown species discoveries, scientists can paint a better picture of Earth's biological past.